Good day everyone! In this video, we will discuss about the application of parabola. In solving word problems involving parabolas, it is very important to note the standard and general forms of its equation and the importance of the vertex, opening of the parabola, and other elements of its graph. Let us have an example. The cables of a suspension bridge are in the shape of a parabola. The towers supporting the cables are 600 feet apart and 80 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable at a point 150 feet from the middle of the bridge? To solve the problem, we need to find first the equation of the parabola that will represent the cables. It will be better if you can illustrate the problem to better visualize the scenario. We can have this figure to represent the problem. Notice that the towers are 600 feet apart and 80 feet high. Considering the vertex of the cables to be at the origin, we can have this figure where points -300, 80 and 300, 80 are both on the parabola and satisfy the distance between the towers and their height. Moreover, since the parabola opens upward with vertex at the origin, then the standard form of the equation will be x squared equals 4py. For us to determine the equation of the parabola, we need to substitute 300, 80 to the equation x squared equals 4py and solve for p. Thus, we will have 300 squared equals 4p times 80. Simplifying 300 squared and 4 times 80, we will have 90,000 equals 320p. To solve for p, we need to divide both sides by 320. Therefore, p is equal to 90,000 divided by 320. Simplifying 90,000 divided by 320, we will have p equals 1,125 over 4. Since we have the value of p, we can substitute its value to the standard form of the equation. Therefore, we will have x squared equals 4 quantity 1,125 over 4 times y. Simplifying 4 times 1,125 over 4, the standard form of the equation of the parabola will be x squared equals 1,125y. Going back to the problem, we were asked to find the height of the cable at a point 150 feet from the middle of the bridge. To do that, we need to substitute x equals 150 to our equation. Hence, we will have 150 squared equals 1,125y. Simplifying 150 squared, we will have 22,500 equals 1,125y. Dividing both sides by 1,125, we will have y equals 22,500 divided by 1,125. Simplifying the right side of the equation, we will have y equals 20. Therefore, the height of the cable at a point 150 feet from the middle of the bridge is 20 feet. I hope that you have understood the lesson. For the next video, we will discuss about applications of ellipse. Thank you so much for listening and see you on our next discussion.